Hi, I just wanted to quickly show this tool that I made called Kanji Builder. And what it does is you can build a kanji. So let's just get a random kanji here to try to build. That one's too easy. Let's get another one. Okay, so this is built of water on the left and bones on the right. So let's just type Sanzui to get the water because that's the name of that radical. And then let's make another component on the right and let's type Hone. There we go. And now if we press enter, the kanji appears right here. So it was able to find it. So a little bit about how this works. It relies on two main resources. The first one is Kanji Dick 2. Here's the home page for it. You can download it here. And this is written by Jim Bream, I guess. So this is related to a couple of other Japanese tools that are online. And the Kanji Dick 2 is used for the readings of the kanji, so you can search by readings, and also the stroke count of each kanji, so you can also search by stroke count. So for example, if I just type like dai, I can cycle through a bunch of kanji that have the reading dai. And also if I type a 4 after it, I get something that can be pronounced dai, which has 4 strokes, or if I type a 3, then I get something that's pronounced dai with 3 strokes, and apparently there are 2 of them. So the Kanji Dick 2 files, let's take a look at that. It's basically just a huge list, and here's an entry for a character. There's the stroke count, which I extracted, and the readings should be in here somewhere. Yeah, Japanese on and Japanese kun, which I also extracted. So you could search by the on or the kun reading in my tool. And I parse those into this kind of format, which is a Python dictionary. That's something else. So that's how I took advantage of that resource. And then the other one that I used was Kanji VG. This is, I think, basically a font, but it's useful to me because it includes information about the composition of the kanji. It shows you what components are in it and how the components are related spatially. So this is the home page for Kanji VG. This is the GitHub right here where you can download it. And yeah, this was required basically so, as you saw before when I created this character, it had to know that it was made of the water radical and the bones. And this is where it got that information from. So I actually parsed that information. Here's an example of what a Kanji VG file looks like. It has the whole character here at the top, and then inside it, it has components. Here's one component that makes it up, and it's positioned on the top. And then here's another component, and it's positioned on the bottom. So I parsed that information into this guy. This is just a list of a whole bunch of kanji and kind of like formulas of how to make them. So this stands for horizontal, 2 components laid out horizontally. First one, Nimben, and the second one, go, I guess, gyo or waza, and there's just a lot of them. Here's a more complicated one. Two vertical components. The first one is this, and the second one is kuchi. So the first one is actually broken down into two more components. And it gets kind of complicated, and I don't want to get into it, how it uses all this, how my tool uses all this, because it's it just gets complicated. Sometimes it has to refer to more than one of these entries in order to figure out what kanji you're trying to build here. It kind of builds it up recursively, or it searches it recursively. So these formulas here were inspired by something called ideographic description sequences. It's basically the same idea. Only instead of H and V, you have these characters. And got a few more for types of enclosures. And you have this one, which is for overlapping kanji components. And I haven't implemented anything like this in my tool, but I do have the some of the enclosures working. For example, I have this T here, which stands for tare, and that's something that goes on the top left side of a kanji. So here it's saying we have a tare of, we have this kind of tare with this on the inside of it. And the K stands for kamae. N stands for nyo. Nyo goes on the bottom left side of the kanji. So I've sort of implemented those, but not fully, because some of them I had to make custom images for. I've made 6 of them here, because these kind of images don't exist in any font set that I could find. Some of them do. Some of the nyos do, like Shinnyo, I believe, does exist as a character in a font set, but some of these other ones I had to create on my own, and I just got tired of it, so I didn't do them all. Now, these IDS sequences also appear on Wiktionary. For every kanji character that I've tried to look up on Wiktionary, I've noticed that they have something like this that says composition, and then it tells you an IDS sequence for it. So if I could scrape all this data off of Wiktionary, then I could use that rather than using Kanji VG. Because I've noticed a few spots in Kanji VG such as this one. A few of the characters have incomplete information, like this heat element is missing the KVG position tag. So you won't be able to create this character using my tool, because it's getting the information from here, and this isn't telling it how the heat and also the die character are organized spatially. So it doesn't know how to build it. It doesn't know how to recognize it if you try to build it. If I could get the information from Wiktionary, it might be more complete, but I haven't done that. Okay, so I thought it might be fun to put this to the test, and I'm gonna generate some random kanji over here and then try to build it. And we'll see how many we can actually build, because not every kanji, well, some kanji have components that aren't easily named or described, so we won't be able to build those. But let's just pick a random kanji and give it a try. This one, I happen to know that the bottom right component is called tatsu, so I think we can do this one. If you didn't know that, you might know that you can read it as shin. But let's start with the water radical on the left. Now, before I made the water radical by typing sanzui, but we can actually just type mizu and then use the spacebar to get variants of that. And there are 3, and sanzui is one of them. Now we have kyoku with 1, 2, 3, 4, 5, 6 strokes. There we go. And then let's try getting it with the shin reading. I'm not seeing it, so let's count the strokes. 1, 2, 3, 4, 5, 6, 7. Is it 7 strokes? Where is it? 1, 2, 3, 4, 5, 6, 7. Maybe it's 8 strokes. There's just too many. So the tool doesn't really come in too useful here unless you happen to know tatsu with 7 strokes. And there we are, we're able to make it. Now let's try a couple more. Okay, I think we can do that maybe. So I'll press Shift T to make a tare, and then just scroll through the ones I have. There we go, that's the one we need. And then we want to put hane in here. All right, that one worked too. We're getting pretty lucky. Let's just do one more. Yeah, and this one we're not going to be able to do because that enclosure I haven't programmed in yet. I do have some similar ones like this one, but there's a couple strokes missing. So we're not going to be able to do that one. All right, so that's how it works. That's pretty much it. Sadly, I'm not the first person to come up with this idea. There's this tool called IDS grep, which does the same thing pretty much, only better in some ways, because it allows wildcards. You can put a question mark in here. So for example, you can search for every character with a moon on the right, like that. And here they are. So I think my tool could be modified to do this with just a little bit of work. But mine has the nice advantage of this interface. And I think this interface would be cool because you could kind of make it like an input method like an IME. So this is my concept art, I guess, of like, imagine you're typing and then you're trying to come up with a kanji and you happen to know the components in the kanji, then you could use this tool to quickly build it and then input it. I haven't done that, haven't implemented that yet, but that's just an idea of what could be done with this. So yeah, that's it. I'll put the links in the description, including a link to this blog entry, so feel free to try it out. Thanks for watching.